Hello, this is Anthony with Copley. Today I'll be discussing how just an interesting application. So here's a layout of my application. I have an XCL, a plus or minus 5 volt analog output from the XCL. That's being fed into an XPC on the plus or minus 5 volt analog, plus or minus 10 volt analog input. So this is just a pin to pin connection. And then I'm using CVM in a loop on the XPC to scale that input value and then transmit that scaled value to a PDO to the MP3. Also, I'm starting and updating a velocity move based on that scaled value. So the XPC will be doing a programmed velocity move, and so will the MP3 connected over CAN using this PDO. So this MP3 is not going to do any of the work really. This is the XPC is doing all the work transmitting the PDO. The MP3 just receives that PDO. So it's just going to one time use CVM on startup to map the PDO to the program velocity, and then it's going to start the velocity move. So that's it. So both of these will move with respect to this XCL plus or minus 5 volt sinusoidal analog voltage. So let's just look at, let me start it and look at the waveforms. So that's the XPC and this is the MP3. So as you can see, they both have the same waveform, which is great. And if I had another serial cable, we could look at the plus or minus 5 volts from the XCL. But yeah, this looks good. The MP3 axis A. You could also do all of the axes B and C as well. You could have doing moves, and then you could have a whole network actually transmitting using this PDO, because the CANopen network is very reliable in terms of timing and messages. So how does this actually work? Well, if I was to, let me stop the program. Well, actually, let's look at it a little bit. So here's the XPC. So this is where we first will map the TPDO. We'll give it a COB ID. This is an event-driven PDO, and we're going to map the CVM register 3 to this PDO. So if we go here and we look at register values, we see that R3 is that scaled value. So the next step, we're starting a velocity move in velocity mode. Then we're going to get the analog volt input and save it to R2. So that's that raw signal coming from the XCL. And then we're scaling it and putting that in R3. So I'm multiplying it times 600 because I'm doing that because the units for the program velocity are in 0.1 counts per second. And then, so next is I'm setting this parameter 108 to 1. That actually transmits the event-driven PDO. So without this, you're not transmitting the PDO, so you need this step. Then we're setting on the XPC the program velocity. So this actually will update the XPC. And then I'm conditionally jumping back. I'm always going to, in a loop, I'm going to be jumping back to step number 3, which is getting that input voltage analog input again, and then scaling it again, transmitting the PDO. So this will be in the loop, this CVM program. Then if we go over to the MP3, the nice part about this is it just has to run this once on startup. So So the MP3 is going to be running this once. So it starts the velocity move at some arbitrary RPM, and then we map the program velocity to that same PDO. So it'll be getting that data and unpackaging it into 2341. And that's it. That's how you would set this up. So I hope this was helpful and in demonstrating a pretty neat application using an input and a lot of Copley drives on a CANopen network.